Okay, I'm back for the second part of our lecture. And here was where we left off, the three main types of sedimentary rock. So the sedimentary rocks are going to be classified, or they're going to be organized according to the type of sediment that make up the rock. The first type of rock, therefore, is clastic rocks. And clastic rocks are simply formed from pieces of other rock. So these rock particles can range in size from very small, which would be clay. You guys should have gone over some of this when you did soil, but clay is like very, very tiny, fine particles of rock, um, to very large boulders, and that would be obviously part of like a conglomerate rock. But okay, hold on. There we go. Clastic rocks are grouped by the size of the rock fragments that make them up. So I gave you over here 4 examples of common clastic rocks that you might see. So shale is the first one, and as you can see this layering, right? Shale is a type of rock that forms from very small clay particles. Obviously, you see there's no visible grains, but you can see the layering of these particles, and oftentimes if you come across shale, it almost like flakes off in the layers. Sandstone, you can see some of the banding here. Not all sandstone is banded, but a lot of, in fact, this first picture that I used is also there we go. That's also sandstone. I believe that's probably part of the Grand Canyon. And so you see the layering here in the sandstone, just like you see it in our rock right here, but it doesn't always have to be layered. But sandstone is going to have a very sandy texture on the surface. And then these two we looked at, I know I passed a sample of this around in class, and we compared it to the breccia. So conglomerate is going to have particles of rock, but they're going to be rounded. And I passed that sample around in class a couple weeks ago. Breccia is going to be like conglomerate in that you see the bigger pebbles of rock cemented together, but they're going to be more jagged. So whereas conglomerate is like rounded pebbles cemented together, breccia is going to be jagged chunks of rock cemented together. But those are clastic rocks. They're just made up of bits of other rock that have been, like we said, weathered and then moved to a new location, and they deposit and cement together. The second type of rock is going to be organic rocks. And organic rocks are formed from the remains of material that was once living or was once part of a living organism. So that can be anything from plant matter, as is the case with coal. Remember, coal is formed when over millions of years you have plant matter that dies, sinks to the bottom of a body of water, decays, and then forms into a rock, into coal. And then here you see another fossiliferous limestone is going to be rock that forms from the shells of clams and coral and other sea creatures that die. And then coquina is, you can see, it's again made in the water, and you have little bits and pieces of shell that are cemented together. So coquina has like a very rigid, almost looks like you took a bunch of shells, put them in a bag with some glue, and formed a rock. But that's coquina. So in each of these cases, you have material that was once living or once part of a living organism forming the rock particles. And then the last type of rock is called a chemical rock. And chemical rocks form when we have minerals dissolve in water solution and they crystallize. So we're in all cases, right, in clastic, in organic, and in chemical rocks, we have these minerals coming into solution, dissolving, seeping in between the particles, and then eventually rehardening and cementing those particles together. The difference is with chemical rocks, there aren't really any other particles they're cementing together. It's just the mineral that was dissolved in solution coming out of the solution and reforming into a rock. And so the easiest way to think about this is salt, right? Like we used our example of putting table salt sodium chloride into water, dissolving it, letting the water evaporate. Eventually that table salt is going to reappear. The same thing happens with rock salt. So rock salt is what naturally forms from the mineral halite, and this is an image of rock salt. So rock salt actually does form a rock, and when halite is in solution, it dissolves, and eventually when that water evaporates, the rock salt reforms. A couple other options, a couple other examples of this are travertine, which you may have heard of travertine. It's used in making like ceramic tile or tile for your floor. And that forms when calcium carbonate, which is a combination of calcium and carbon, go into solution and then come back out of the solution. And the same thing with limestone. This limestone is different from the phospholiferous limestone, because the phospholiferous limestone is going to use the calcite that is in the shells of the coral and in the other sea creatures. And this is from calcite that is just dissolved in water. It's not necessarily part of a shell or a coral structure. It's just calcite dissolved in water that then again comes out of solution and reforms into limestone. So those are examples of chemical rocks. All right, how are sedimentary rocks used? Again, just like with our igneous rocks, sedimentary rocks are going to be pretty much have two main purposes throughout history. One, they're going to be used to make tools and weapons. Like we see here, we have chert, which is one type of sedimentary rock that various native people, thousands of years ago used to make different tools or weapons. Same thing with flint. And again, these are rocks that when you that you are able to shape into a point. So it makes them useful for cutting tools or for weaponry. And then the other main use that these rocks are going to have is in building. And so here's one example. The White House is actually made of blocks of sandstone, and the Lincoln Memorial is made out of limestone. And that's just two examples. There's many, 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 many buildings in urban areas, religious structures that are built from big blocks of stone, and oftentimes those big blocks of stone are sedimentary rock. All right, so that ends our lecture for today. You should have the ability at this point to answer all the Q&A. I do want to point out, I don't think I did already, in the stream, I have posted our online Zoom meeting for tomorrow. So I want to get in the habit of seeing you guys like once a week. I think it's good for me to see you, and it's good for you to see each other. So we're going to do a Zoom meeting tomorrow for our class. It's going to let me quickly go through what I want you to do for the little sedimentary rock activity that we're going to do, which is going to be very similar to the igneous rock activity we did, and I'm going to go through that tomorrow. But I'm not going to post a lecture. I'm coming on to Zoom. For course 2, it's going to be at noon. For course 1, it's going to be at 12:30. And so to launch your, to get into the meeting, all you do is click on this link down here, and just make sure when it asks you to allow access to your video that you give it permission, so that way we're able to see you, as well as audio, so we're able to hear you. And we'll work through Zoom tomorrow. I know a couple of you came to my office hours Tuesday, but for the rest of you, we'll get used to it, and this way we're able to see each other at least once a week while this goes on. All right, that should be it. So if you have any questions, feel free to upload them to the doc. I'm always checking that and answering questions, or I will see you tomorrow. Have a good day, guys.